Hi, welcome to the lecture on Introduction to Computational Intelligence. So, what is intelligence basically? If you look at this, intelligence as a term, it is the ability to learn or understand or to deal with a new situation. Intelligence can also be defined as the ability of a system to adapt its behavior to meet its goals in a range of environments. So, intelligence is also a property of all purpose driven decision makers. So, these are various definitions of what you can talk of about intelligence. The next obvious question is, can computers be intelligent? So who is going to be smarter, you or the computer? So the answer to this question is increasingly complex, and it basically depends on the definition. So, if you look at the learning capability of today's computers learn much faster than humans. For instance, the IBM Watson computer could read and remember all the research on, say, cancer that no human could. So, how is this all possible? So all these are possible by what we term it as the AI. The buzzword is AI. AI is artificial intelligence. So what is artificial intelligence? Artificial intelligence refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. So, most of the examples that you hear based on artificial intelligence, like the chess game playing computers, so self driven cars, and so on, are all simple examples of what an AI, the artificial intelligence, could achieve in this century. So AI basically mimics the human brain and their actions, and the machines are exactly programmed as how they could probably mimic human actions. So what is AI? So AI is the ability to learn or understand or deal with a new situation. So, the study of how to make computers do things at which people are doing better is what is called artificial intelligence. So, artificial intelligence is one of the most emerging areas in computer science that basically deals with techniques that could probably create intelligent systems. So whenever I talk of what is called the intelligent behavior, it includes perception, reasoning, learning, communicating, and action, and all these need to happen in a complex environment. So if you want to know how probably AI has emerged, so if you look at the 1940s, the most famous scientist, Turing, said, "You cannot make a machine to think for you." In 1956, McCarthy basically organized a Dartmouth AI conference at the Dartmouth College. Then, somewhere in the 1990s, Zadeh basically talked of, differences between hard and soft computing, and 2007 was the year in which computational intelligence was basically getting up, and the introduction to computational intelligence evolved sometime in 2007. So, what is CI? Computational intelligence is a subset of AI, artificial intelligence. CI is synonym to soft computing. So, what is CI? CI basically refers to the ability of a computer to learn a specific task from data or experimental observation. So, when you talk of CI, that basically comprises of practical adaptation and self-organization concepts, paradigms, algorithms, and their implementations. CI basically talks of how a computer could learn a specific task. It could learn from data or experimental observation. So CI is basically considered to be a sub branch of AI. It is concentrated in the study of adaptive mechanisms to enable or facilitate intelligence behavior in a complex and a changing environment. So, whenever you look at hard computing versus soft computing, hard computing basically, relies on precision and certainty. Soft computing basically, relies on imprecision, uncertainty, and what we term it as partial truth. So, if you look at computational intelligence concepts, we have some keywords or buzzwords in CI like the ANN, the artificial neural networks, evolutionary computation, swarm intelligence, artificial immune systems, and fuzzy systems. And each one is a separate area of emerging research. So, why CI is important is another obvious question. So, computational intelligence can be studied for problems where there are no effective algorithms because it is not possible to formulate them, or they might be NP hard and they are not effective in real life applications. So, if you look at computational intelligence research, it basically revolves around perception, object recognition, signal analysis, and so on. So, there are suitable methods that are developed to solve these type of problems that are basically categorized under two umbrellas called the supervised learning and unsupervised learning. When you talk of supervised learning basically is nothing but learning under the supervision of a teacher. So, supervised learning, a simple example could be our class where you all learn under my supervision, and that is called supervised learning. Unsupervised learning is learning in the absence of the teacher, and this could probably be correlated to what we term it as, say, a self-study topic, and that is basically unsupervised learning. So there are some common myths. Myths means untruths that are revolving around the computational intelligence. The first myth says AI works like the human brain. So artificial intelligence is a computer engineering discipline. So it consists of a set of tools that are basically aimed to solve certain problems. So AI might give you an impression of being clever, but it would be unrealistic to think that the current AI is similar to human intelligence. So there are certain forms of ML called the machine learning, which is a part of the AI inspired by the human brain, but they are not equivalent. Image recognition technology, for example, could be more accurate than humans, but will be of no use when it comes to solving a math problem. So, AI basically solves one task exceedingly well, but if you change the conditions, then it will miserably fail. So AI might work like a human brain, but it might work well for one single task. If the conditions change, then it will miserably fail. The next myth says intelligent machines learn on their own. When you look at an ML product that is finished, you might get an impression that it might learn on its own. However, you should understand that this has come from experienced human data scientists who have framed the problem, prepared the data, then looked at suitable data sets. They have removed the potential bias on the training data set, and very importantly, they will update the software to enable the integration of new knowledge and data into the next learning cycle. So without this human scientist, the intelligent machine would not have come into this world. Myth 3: AI can be 100% objective. No, every technology is based on data, a set of rules, and other kinds of input from human data scientists or experts. Because all humans are intrinsically biased in some way or the other, the artificial intelligence system also is biased in some way or the other. So, for example, using new data from social media or even more vulnerable to unwanted bias, and that is very much obvious. Myth 4 says AI will only replace mundane jobs. AI enables businesses to make more accurate decisions via prediction, classification, and clustering. For example, you look at the use of an imaging artificial intelligence in healthcare. You can probably look at a chest x-ray application that is based on artificial intelligence that could probably detect diseases much faster than your radiologist. So basically, you look at robo advisors used for wealth management and fraud detection, and you cannot completely eliminate human involvement in all of these tasks. Probably you can limit it, but you cannot totally eliminate it. Myth 5: my business does not need an AI strategy. No. For every organization, you consider the potential impact of AI on the strategy and the technology. In many ways, AI is being used for automation, and even if your current AI strategy is no AI, This should be a conscious decision based on research and consideration. So you should obviously periodically revisit your decision, and you should obviously adapt to the needs of the organization. So you cannot totally avoid this AI strategy in your business as well. So when you look at the major components of computational intelligence is said to be made up of three main pillars. Neural networks is one pillar, the next one is fuzzy systems, the next one is evolutionary computation. Recently, there is one more pillar that is being added to it, and that is what is called swarm intelligence. So now you could obviously say, there are four pillars of CI: neural networks, fuzzy systems, evolutionary computation, and swarm intelligence. So we talk of what is the basic difference between soft computing and hard computing. When you look at hard computing basically relies on binary logic. So when I say binary logic, it is either 0 or 1. So you have a set of predefined instructions, and it uses what is called a two-valued logic or a binary logic, 0 or 1. Many traditional conventional algorithms work using hard computing, like sorting algorithms, greedy algorithms, dynamic programming, and so on. When you look at soft computing is basically talking about the model of the human mind that basically involves probabilistic reasoning, fuzzy logic, and multi-valued logic. So it is not constrained to 0 or 1. For example, in the medical field, you have computer-aided diagnosis, you have handwriting recognition and fraud detection, and so on, and all these work using what we call it as soft computing. So if you look at key differences between soft computing and hard computing, soft computing is tolerant to imprecision, uncertainty, partial truth, and approximation. Hard computing basically relies on precisely stated analytical model. Soft computing looks upon fuzzy logic, neural network, and probabilistic reasoning. Hard computing basically looks at binary logic, and we talk of something called the CRISP systems, numerical analysis, and CRISP software. Soft computing will be able to evolve its own programs. Hard computing programs need to be written. Soft computing uses a multi-valued logic. Hard computing uses what is called a binary logic or a two-value logic, 0 or 1. Soft computing is ambiguous and noisy data, where hard computing uses exact input data. It is possible to perform parallel computation in soft computing, whereas hard computing is strictly sequential. You might get some kind of approximate answers in soft computing, whereas you can always expect precise answers in hard computing. And this basically shows some key differences between hard and soft computing. So if you look at certain differences between artificial intelligence and computational intelligence uses soft computing techniques, whereas AI uses hard computing techniques. CI follows a fuzzy logic. It is all coming from nature-inspired models, and you can work with inexact and incomplete data. But AI follows a binary logic that basically strictly follows a mathematical model, though not very effective, basically provides deterministic results. So AI is hard computing, CI is soft computing. You have fuzzy logic, neural networks, evolutionary computation, and still you can also add swarm intelligence recently as well. So when you look at the pillars of computational intelligence, the first is neural networks. Neural networks are basically inspired by biological neural systems, where a neural network has an ability to learn, memorize, and also generalize. You have suitable techniques like the perceptron, single layer perceptron, multi-layer perceptron, Hopfield networks, coherent networks, and so on. Artificial neural networks finds its applications in time series approximation, pattern recognition, clustering, associative memories, optimization, etc. If you look at evolutionary computation has its objective to mimic processes from natural evolution. Genetic algorithms, genetic programming, and evolutionary strategies are some concepts that come under the evolutionary computation. Evolutionary computation finds its applications in data mining, combinatorial optimization, fault diagnosis, classification, clustering, and time series approximation. If you look at fuzzy systems are basically inspired by human reasoning or approximate reasoning. We have suitable techniques for fuzzy systems that include, fuzzy inference systems, fuzzy c-means, and fuzzy systems basically find its applications in control systems, gear transmission, braking, controlling lifts, classification, clustering, and function approximation. So when you look at applications of computational intelligence in real world problems, there are numerous applications of CI, right from real time water treatment process control with artificial neural networks, classification and diagnostic prediction of cancer, hybrid approach to solve team allocation problems, classification of social network users, sentiment classification, improving performance of IoT applications, and so on. Another application of CI in real world problems includes robotics, NLPs, facial and speech recognition, game playing, healthcare, finance and banking, machine learning, military equipments, and so on. So there are a wide variety of applications of CI that could be applied to real world problems. So where do CI be used? The most common application of computational intelligence that even kids use is the Amazon Alexa. Amazon Alexa uses computational intelligence. Other major companies that use computational intelligence are GraphCode, Facebook, Nvidia, HiSilicon, Intel, and Google. This is only a partial list of top companies that are working with computational intelligence. And Alexa has some kind of computational intelligence built into it, and lot of things are even getting added to it on a day-to-day basis as well. So how do I implement computational intelligence on real world problems? In order to implement computational intelligence on real world problems, there are numerous tools that are available. A researcher needs to use CI techniques, so he might definitely need a lot of tools. So for instance, with respect to programming languages, we have Java, Python, and C++ most effectively used in writing code for CI problems. In addition to the programming languages like Java, Python, and C++ that are available, there are certain frameworks or tools or APIs that are available for implementing computational intelligence and solving CI problems. So some of the tools are RapidMiner, Vika, Neurof, Azure, Google Prediction API, JFuzzy Logic, JMetal, and so on. So this has given you an overall understanding of what is computational intelligence and what is artificial intelligence, what could be done using computational intelligence, what are the different pillars of computational intelligence, and what are some of the tools that are available in computational intelligence. So, stay tuned for more video lectures on computational intelligence. So this basically gives you an overall understanding of CI. So stay tuned for more video lectures on CI. Thank you.